That is, in the last session, we have discussed about RDL, resistor diode logic. So by using that, we have analyzed the operation of unlogic families or logic families. Okay. Similarly, all the logic families we are going to discussing in the forthcoming sessions. With this, we have to understand certain fundamentals, that means definitions. Already you might have studied in other subjects. Say, for example, in your linear integrated circuits or digital signal processing, if suppose you completed, means you might have heard about this particular definitions. So in all the digital logic families which we are going to discussing is having certain important definitions, or you should keep it in your mind. What are all the terminologies or terms? The first one is threshold voltage. So the first one is threshold voltage. It is not a new terminology to you, because the same word you might have studied in your electronic circuits. That means threshold voltage or knee voltage in the VI characteristics of a PN junction diode at least. So the device which is going to turn down at which voltage. So that particular voltage is called threshold voltage. There is a minimum voltage required to turn on the device. So like that you might have studied. The same thing only here, it is a voltage level which is used to change the state. So this is the first one. Second one is propagation delay. I think this is also familiar to you people, because in some sessions before we have discussed this particular terminology, that is called propagation delay. Propagation delay in the sense, whenever we give any input to the digital circuits, the output will not be in that same incident itself. Say, for example, the system or a digital circuits may change its states or level from one to other. For example, 0 to 1 or 1 to 0 or low to high, high to low, whatever may be the states. So according to that, we are going to define this propagation delay. Say, for example, if suppose you are giving any input, hence it changes the state from 0 to 1, means not at t equal to 0th incident. That means instantaneously is not possible. It takes few seconds, it may be a milliseconds or a microseconds delay. That is called propagation delay. And then third definition is power dissipation. It is also not a new terminology as electrical engineer. As electrical engineer, it is not a new terminology, because you might have studied the same definitions or a same term in your electrical machines or circuit theory. Similarly, here also this terminology is called power dissipation. During the process of any digital applications in a digital circuits, what is the power dissipation during that process? What is the power dissipation? So we are going to discussing such a things as also in this unit. And then next definition is fan in and fan out. Next definition is fan in and fan out. It's another one terminology. Fan in means how many numbers of inputs is there. That is fan in. Fan out means it's opposite. That means how many numbers of output is there. Sometimes in some books, this fan out is represented as a loading factor. It means that how many loads can be connected, how many outputs can be connected with the load. So based upon that, it can be defined. So anyhow, it is another two definitions. One is fan in, fan out. That means the number of inputs and outputs. And another definition is voltage and current parameters. Voltage and current parameters. It is also not a new thing, but anyhow, for refreshment, I am going to giving the definition for this. Voltage parameters, current parameters means input voltage, that is VI, or output voltage V out. I think no need for this terminology explanations. The voltage at the input terminal or in the input terminal is how much, that is called input voltage. Similarly, in the output terminal, what is the voltage across the output terminal, that is called output voltage. Similarly, I in and I out, I in and I out. Then noise margin. Noise margin is another one factor you have to keep it in your mind while you are going to designing any digital circuits. So it is like one bar chart graph like that. What is the low and high level noise margin? Low noise margin value is how much, and high level noise margin is how much. It should be known by the designer. And then the last one is the speed of operation, or operating speed, this is called speed power product. This is called a speed power product. So these are all the important terminologies you should know, even if it is in our exam point of view, or in case if in future you people may join in any industry as a design engineer, you should know these parameters. Okay. Then, so far we have discussed many definitions. Is it new thing or a already familiar one? That is the next question. No doubt, knowingly or unknowingly, if people already know all the terminologies, either from the fundamental subjects, or in case if any electronics or digital electronics or linear integrated circuits based laboratory courses is there, means all the courses you should gone through this, or at least go through this terminologies only. When? Next question is when. In case if any design experiment is there in the laboratory courses, for that you have to refer a data sheet. I think this word you might have heard in our lab courses. That means data sheets. Data sheets of what? Data sheets of the device which we used in the laboratory. Data sheets. The same thing only, the data sheet concept only available in the electrical machines, that is called nameplate details of the machineries. Nameplate details of the machineries. So in that name, anything else, pa? So any doubt? Can I continue? Pramanandan, can I continue, pa?
Oh, sir. Yes, sir. Continue, sir.
Okay. I think there's some disturbance. Okay. So in your laboratory courses, you might have gone through these two things, either data sheet concept or a nameplate details. So that two things gives all the above informations. So if it is an electrical machines laboratory courses, means in case if it is nameplate details, means it gives all the details, technical details, the rating of the machine, maximum voltage, minimum voltage, what is the resistance or insulation level, the winding temperature withstanding is how much, which type of machineries or which type of connections is given. That and all you might have studied, or you might have practiced in your lab courses. Similarly, there is another one concept or another one thing is available in a practical courses or lab courses, that is called data sheet concept. So what are all the things available in that data sheets? It gives, or it has all the informations of the device which you are going to using, or which you are going to utilize in the application. It means that what if, say for example, if suppose I'm going to select a transistor, a simple transistor may be used for my digital circuit, that's the application is maybe an inverter. So I have to refer what is the input voltage level, output voltage is what, and then maximum power withstanding is how much. And then one more thing you might have studied in your electronic circuits, peak inverse voltage value is what, voltage rating, current rating, and the power dissipation level, the temperature withstanding is how much. இதெல்லாம் நீங்க அதுல பார்த்திருக்கலாம் sir, data sheets. In case if you people are not practiced, at least you please gone through with any YouTube videos, it will give the more valuable informations to you. Okay, so these are all the basic informations, even if it is the logic family is in any type. So the last class discussion is RDL, that means resistor, diode, transistor, or resistance diode logic, or RTL, resistor transistor logic, or a transistor logic, or whatever may be the logic we are going to discussing. Everything is having these parameters. Okay, then what is propagation delay? No need of explanation. There is a small time needs for transition from one state to other state. That is, a time needs are required for pulse to propagate from input to output, or logic level to logic 1. Then what is the fan in? Fan in means the number of inputs I already told. So what fan out means number of outputs, or how many numbers of load terminals are there. The same thing, number of output தான் என்னங்க சார் சொல்றாங்க, எத்தனை load terminals are there. Load terminal என்னங்க சார், from the output terminal we can connect the loads, அதனால அதுக்கு பேரு load factor. Okay, so we call that as a load factor. And then it is very important thing in your design part, fan in fan out, because for which application you are going to design a circuit, for that how many numbers of output pins you need, how many numbers of input pins you need, இதெல்லாம் உங்களுக்கு தெரிஞ்சிருக்கணும் சார், சரியா? And then noise margin, that means each and every digital application circuits is having, there is a disturbance, a form of unwanted signal is there, but what is the level of negligible value, or tolerable value, or adjustable values, or allowable values, சரியா? So the noise immunity is the ability of a circuit to tolerate the noise voltages or noise currents, okay, at the inputs as well as outputs. The same thing you might have studied in your any other microprocessor based experiments, means keyboard interface circuit is there, means there the same thing in another way, debouncing keyboard la, even if it is in your computer keyboard or your button type mobile phones, அதெல்லாம் நீங்க உங்க கீபோர்ட்ல பிரஸ் பண்ணும்போது it is there, this noise margin you can realize. That means whenever I press either button 1 or 2 and then I release, under that situation pressing and releasing la, not exactly it is going to reach the final state or final level. Na press panna odane povadhu sir, it takes some duration. In that particular duration itself, there is a noise voltages, it is in zigzag, that it is in zigzag in the sense noise, that means a transient voltage like waveforms. That means it takes some time durations to settling time, like in your control system subjects la padicha mariyana vishayangalla illa irukum sir. Okay, and then speed power product, that means it is another one important thing. So the same thing only in a processor speed nowadays in your computer or laptop when you are going to purchasing, or even if it is in a mobile, இதெல்லாம் அதுல இருக்கும் சார், சரியா? So how much it works fast, that is propagation delay based one. என்னுடைய propagation delay எவ்வளவுக்கு எவ்வளவு நான் குறைக்கிறேனோ that much amount of speed up of processor may be possible. Yes, so this is another one important slide to you, because in your examination point of view there is a possibilities of asking a question definition for propagation delay. So the same thing, so far whatever we have discussed, the same thing only. So this is the input, this is the input pulse, and this is the output pulse. So listen carefully, this is the input pulse and output pulse here. So what will happen here, you please see here, till this it is low state or a zero, here it changing either like this or at least like this. So இந்த இடத்துல இந்த மாதிரியோ அல்லது இந்த மாதிரியோ சேஞ்ச் ஆகுது, so இந்த மாதிரியே இந்த மாதிரி சேஞ்ச் ஆகுது, but see the same place in the output waveform. இந்த output waveform ஆக்சுவலா என்னங்க சார் ஆயிருக்கணும், எனக்கு நான் எப்ப இங்க சேஞ்ச் பண்ணணும் அங்க அந்த டைம்லயே இங்க சேஞ்ச் ஆயிருக்கணும். அதுக்கு ஆப்போசிட்னா because it is inverter. Please listen, because it is inverter. இன்வெர்டர்னா நான் என்ன 1ன்னு சொன்னா இங்க 0ன்னு வந்துடணும், 0ன்னு சொன்னா 1ன்னு வந்துடணும். ஆப்போசிட்ல தான் இருக்கும். அதுதான். அப்போ நான் இந்த சைடு போறேன் அப்படின்னா அப்போ ஆப்போசிட்ல வரணும். அதான் இங்கேயும் நடந்திருக்குது. Here also the same happening. So if it is increasing from 0 to 1, 0 to 1 increasing, here இல்ல அங்க போய்டா, here 0 to 1 increasing, இங்க என்னங்க சார் இருக்குது, இட்ஸ் ஆப்போசிட். அப்போ 1 to 0 ஆர் மைனஸ்ல போகுது. பட் இட் இஸ் நாட் ஹேப்பனிங் அட் தட் இன்சிடென்ட் இட் செல்ஃப். இந்த இன்சிடென்ட்லயே நடக்கல. ஸோ இட் டேக்ஸ் சம் மினிமம் டூரேஷன் ஆஃப் சேஞ்சிங் த ஸ்டேட்ஸ். ஸோ இந்த மாதிரி நடக்கிறதுக்கு பேரு தான் என்னங்க சார், ப்ராபகேஷன் டிலே. ப்ராபகேஷன் டிலே. நாட் ஓன்லி ஹியர் the same thing, because of this occurrences it will be reflected in the output side also. So எனக்கு இன்புட்ல இந்த மாதிரி ஒன்று நடக்கிறதால the same thing will be reflected in the output. சரியா? So in our examination, if it is in either a 2 mark question or a big question, so you have to write everything. இது எல்லாத்தையும் எழுதணுங்க சார். Propagation delay na it is a minimum time durations take the transition period. In the transition period of pulse changing in the input and the output. அதுதான் இங்க நம்ம சொல்லி இருக்கிறோம். இந்த டயகிராம் வரைஞ்சிர வேண்டியதுதாங்க சார். Then it is a general formula. Propagation delay is a average time duration of changing from one state to other state. That means low to high and high to low, low to high and high to low transition. இங்க இருந்து இங்க போறதுக்கும் திரும்ப இங்க இருந்து இங்க வந்து finally it reaching the original positions க்கு வர average time duration தான் propagation delay. So each and every circuit is having this. எல்லா சர்க்யூட்டுமே இந்த propagation delay இருக்குங்க சார். We have to reduce it. இதை reduce பண்ணணும். Why? Then only we can increase the processing speed. Okay, next definition. Again, it is also for exam point of view. So power dissipation means, you know, according to the fundamental, P is equal to VI according to the Ohm's law. The same thing only, nothing new I am going to explain to you. இதுதான் நீங்க இங்கேயும் படிக்க போறீங்க. But here it is a different explanations. That means power dissipation in any devices is the formula of this VCC is in all the cases is in its biasing voltage. If it is a DC இருந்துச்சுன்னா இது என்னங்க சார், biasing voltage. So voltage into the current, voltage into the current. So current in the sense it is average current of how many numbers of devices is connected in a same source. That means here this is the source voltage or a biasing voltage exactly, or a supply voltage in some books. So இதுக்கு பேர் என்னங்க சார், biasing voltage. Say for example any circuits in your electronic circuits, இங்க என்னங்க சார் பண்ணிருப்பாங்க, plus VCC அப்படின்னு கொடுத்திருப்பாங்க. சரியா? Then base emitter collector, from this output is taken, here input is given. Okay, it is a simple inverter circuit. So this is the circuit. Here this plus VCC is a supply voltage, but the actual thing is it is not only supply voltage, it is the biasing voltage. இதுக்கு பேர் என்னங்க சார், biasing voltage. It gives the biasing to the circuit. So here I am mentioning only one circuit, but in our digital logic family circuits or digital circuits, there are n numbers of switches is connected. Say for example in memory la last class la paatha, last part of this same unit we have discussed, the memories are designed or arranged in a structure. என்ன ஸ்ட்ரக்சருங்க சார், ஒரு மேட்ரிக்ஸ் ஸ்ட்ரக்சர்ல பார்த்தோம். அப்ப n numbers of switches are connected. Each and every switches is having its ground as well as plus VCC. So at the time of triggering or in its operation, there is a possibilities of current flow, that's average. அதுதான். அப்போ இது என்னன்னு உங்களுக்கு தெரிஞ்சு போச்சு. Power dissipation of any digital logic circuit is this. It is the average current. Average current of what? Since it is a digital logic circuit, so this average circuit is also given here. It is the average value of current of the both states, low as well as high state, low as well as high state. So this is a I average. and then n is equal to what? N na n is terminology or term which indicates how many numbers of stages or switches are used. எத்தனை ஸ்டேஜ் அல்லது எத்தனை ஸ்விட்சஸ் நம்ம யூஸ் பண்றோம்ன்றத சொல்லுதுங்க சார். So I repeat once again, nothing new. நான் எதுவும் புதுசா சொல்லிங்க சார். Power dissipation according to the Ohm's law fundamental, P is equal to V into I. So இங்க V என்ன சொல்லுது அப்படின்னா, V indicates a supply voltage or a biasing voltage. Supply voltage or a biasing voltage சொல்லுதுங்க சார். Then I indicates what? Since it is a digital logic circuit, so there is a possibility of changing of states either low to high or opposite. That means high to low. Low to high liyo, high to low liyo ஒரு changes இருக்கும். Under this situation there is a possibilities of changes of currents. அதோட ஆவரேஜ் தான் இந்த இடத்துல சொல்றோம். And then ஒரே ஒரு switch இருந்தா அப்படியே எழுதிக்கலாங்க சார் V into I, but n numbers of switches are connected in parallel. Again another important thing, அப்ப நீங்க V கேட்கலாம். Majority of the cases the voltages are connected in parallel. Voltage circuits parallel தான் இருக்கும். கரண்ட்டும் parallel தான் இருக்கு சார். டிவைசஸ் இருந்துச்சுன்னா it is divided. Parallel circuitsல current vary ஆகும் சார். Voltages are same. So only the varying current is given here. So இன்னும் சிம்பிளா சொல்லணும்னா V into change of current. This is del change of current. V into del I. V into del I equal to P, power dissipation in a device. So அதனால தான் சொல்றேன், I am not telling anything new here, but since it is a digital logic circuits, many numbers of switches are used, so you should know what is BCC, what is I. That's all. I think I am giving a clear explanation to you about the power dissipation. Then coming to the fan in and fan out. Fan in and fan out, that means load factor. Already I have told to you how many numbers of loads can be connected in a logic circuit. That means how many numbers of output pins is there. That is the loading factor. So in this case, this many numbers of outputs can be connected either like this or like this. Similarly, what is the possibilities of, or what are the number of inputs is there in a circuit? That is called fan in. That is called fan in. And then coming to the voltage and current parameters, it is also no need of explanation to you, but anyhow, VIH, that is minimum input voltage, output voltage minimum, input voltage maximum, output voltage maximum, input current minimum, input current maximum, output current minimum, output current maximum, all are under which state? That means low level or high level. So over level there is a current and voltage is there, that is called voltage and current parameters. So coming to the noise margin, that means a deviations or a difference or a variations of signals producing the noises. That means like this, the level only I am mentioning here. So either this much level or this much level. So the majority of the cases as an average is above and below the ranges. That means in the level la mattum sir ella edathiliyum average ah irukum. So our extreme aim is to reduce this. If suppose a circuit is having a high noise margin, அப்படினா என்ன செய்யணும்? We have to reduce it. Other bringing into either below this low margin level or at least we have to retain the low margin level. That is depending on the manufacturer ratings given. That is in data sheet. அப்ப உங்களுக்கு data sheet பார்த்தா தான் இது என்னன்றது தெரிஞ்சிக்க முடியுங்க சார். So these are all the majority of definitions may be possible in our exam. சரியா? Now I am entering into the actual subject. Coming back to the subject. So this and all already we have discussed. This is, that is RTL, resistor transistor logic, DCTL, direct coupled transistor logic, direct coupled. அப்ப வேற ஏதாவது indirect coupled இருக்குதா? Next question maybe wired logics, wired coupled transistor logic. அப்படின்னா the output of one transistor can be directly connected to the another transistor. Say for example like this. So இந்த மாதிரி ஒரு சர்க்யூட் நீ எங்கேயாவது பார்த்திருக்கலாம். So without any just a so this might have you studied in your fundamental electronic circuits. இந்த மாதிரி இங்க என்ன பண்ணிருக்காங்கன்னா the emitter terminal of the first transistor is connected to the base terminal of the second transistor. This particular connection is called ஏதோ ஒன்னு படிச்சிருப்போம். என்னங்க சார் அது? This is called Darlington pair connection அப்படின்னு ஒரு கனெக்ஷன் படிச்சிருப்போம். To increase the speed of operation or to increase the current carrying capability அப்படின்னு படிச்சிருப்போம். So here directly the terminals are connected. In some other cases through the resistance to avoid any problems. That means protections may be given by introducing a resistor or by wired. அதுதான் அதனால தான் இந்த இடத்துல நான் சொல்றேன் direct coupled transistor logic. And then DTL, no need of explanation, that is diode transistor logic. Then another one logic is also there, that is called high threshold logic. This means based upon the operating time. That means when my device is going to be turned on. High threshold logic. So say for example my threshold voltage is 0.6 to 0.7 in an ordinary diode. If it is in some other devices not in 0.6 to 0.7, it may be 1.5 to 1.6 in industrial applications. So that is called high threshold logic. And then this is ordinary things: transistor logic, transistor logic, and then emitter coupled logic, and then integrated injection logic. These are all the evaluation of a digital logic families. Then MOS, CMOS, NMOS, PMOS. Nowadays another developments is also there. For this you have to refer certain companies, that is chip manufacturing companies, Texas Instruments or any other chip manufacturing companies எல்லாம் இத பாத்தீங்கன்னா உங்களுக்கு தெரியும் சார். Yes, again another important point that is in your competitive examination point of view. That means this part, this particular logic is used in SSI and MSI. It means that what? SSI means small scale integrated circuits, medium scale integrated circuits. So this classification is based upon the number of devices is in a chip. ஒரு டிவைஸ்ல எத்தனை number of devices is integrated. ஒரு சிப்ல ஒரு ஐசில எத்தனை டிவைசஸ் வச்சிருக்காங்க அத பேஸ் பண்ணிட்டு நம்ம சொல்றதுங்க சார். So say for example 0 to 100, 100 to 1000, 1000 to 10000 and above 10000 அப்படினு வச்சிருப்பாங்க சார். You might have studied in your linear integrated circuits. Otherwise you please refresh yourself from the fundamental basics ல நீங்க படிச்சிருப்பீங்க. Okay, anyhow, so that is called a small scale integration and medium scale integration. And then this is emitter coupled logic. Very important question in this topic, in case any 16 mark questions in your end semester examination, there is a possibility of question in this part. That is emitter coupled logic, which is used in any places for improving the speed or increasing the speed. That is only given here. That means to attain the super fast speed in a computers, that is super fast computers. Then another one logic is IIL or I square L logic in some authors. So in the IIL என்றது அப்படியே கொடுத்திருக்க மாட்டாங்க சார். In some books, foreign authors, they mentioned this as a I square L logic. I square L logic. So what is mean by this? Integrated injection logic. So based upon the injection concept, many numbers of switches is integrated in a chip. So எந்த மாதிரி இதுனா, nowadays the recent days this kinds of devices only we are using. எல்லா சிப்லயும் இதுல தான். Say for example lakhs and lakhs of devices in a single chip. ஒரு 5 லட்சம் switches, 5 லட்சம் devices ஒரே சிப்ல வைக்கணும் அப்படின்னா அதெல்லாம் யூஸ் பண்ணிருப்பாங்க சார். Under which concept? That is VLSI, ULSI. Very large scale integration, ultra large scale integration, very logic and ultra logic scale integration. Okay, and then MOS, CMOS logics, these are all used up to the level of SSI, MSI, LSI, small scale, medium scale, large scale integration. So it is very important thing, you should keep it in your mind for your competitive examination. Okay, now these are all another important concept, you should keep it in your mind for understanding the operation. That means these two terminologies, one is saturated and non-saturated logic. What is meant by saturated and non-saturated logic? So like these kinds of graph is there in your electronic circuits or ஏதோ ஒரு இதுல hysteresis loop அப்படின்னு கூட படிச்சிருக்கலாங்க சார். So here up to this there is a possibilities of increasing, then saturation, then அடுத்த லெவலுக்கு வரும்போது என்னங்க சார், இது வரைக்கும் வேரியேஷன்ஸ் இருக்கும், அதுக்கு பிறகு சேச்சுரேட் ஆயிடும் சார். இல்ல என்னால இதையும் அண்டர்ஸ்டாண்ட் பண்ணிக்க முடியல, நோ ப்ராப்ளம், you have to take like this. So NPN transistor output characteristics, so from here to here it is increasing and then it is reaches a saturated value. So this is called what, saturated and unsaturated based upon this operations. So இதெல்லாம் நம்ம பார்க்க போறோம். என்ன லாஜிக், எல்லா லாஜிக்குமே இதுல வந்துருச்சு. RTL லாஜிக், DCTL லாஜிக், DTL, HTL, TTL, I2L எல்லாமே இதுல இருக்குங்க சார். Okay, and then non-saturated, that means Schottky diode அப்படின்னு ஒன்று எலக்ட்ரானிக் சர்க்யூட்ஸ்ல படிச்சிருப்பீங்க சார். Like this Schottky diode அப்படின்னு ஒன்று படிச்சிருப்பீங்க. So this is a Schottky diode, ordinary diode இல்லாம இந்த மாதிரி ஒரு diode, சரியா? So இதுல ஒரு பிரேக் டவுன் வந்து நம்ம ஓவர் கம் பண்றோம் ஆர்டினரி டிவைசஸ்ல இருக்கிறத. So in certain applications that is necessary, so we are going to use such a things as, why, to get the fast response, that means speed and output or speed in operation. அப்போ இந்த இடத்துல அப்போ there is no possibilities of saturation in its operation. Then MOS families, subclassification P, N MOSFETs, and then complementary MOSFET. Complementary in the sense a part of the MOSFET, either PMOS or NMOS, is used as a inverter. ஒரு PMOS NMOS inverter யூஸ் பண்ணிப்போம், ரிமைனிங் பார்ட்ல இருக்கிறது மட்டும் தான் switches. We will discuss such operations also later. Then coming to the another one important thing, that is a comparison of logic families with the important parameters. So far what are the parameters we have discussed, accordingly the comparisons. So here these are all the logic families, these are all the important logic families now used in all the circuits. ஃபெமிலியரா யூஸ் பண்றது தான் இதுல இருந்து பழசெல்லாம், தட் மீன்ஸ் RD எல்லாம் இப்ப நம்ம நிறைய யூஸ் பண்றதுல, அதனால அதெல்லாம் விட்டாச்சு. ஓகேங்களா? So based upon this logic families consideration, what are all the things is there? That means, say for example, if suppose I am going to select one particular logic, இந்த லாஜிக்கை நான் யூஸ் பண்ணி ஏதோ ஒரு டிசைன் பண்றேன்னா, what is its cost factor? காஸ்ட் ஃபேக்டர் இதுல கம்மியா இருக்கும். சேம் அப்ளிகேஷன்ஸுக்கு வேற ஏதாவது ஒன்று எடுக்கிறேன், இந்த லாஜிக் எடுக்கிறேன் அப்படின்னா அதோட காஸ்ட் ஃபேக்டர் மேபி ஹையா இருக்கும். Like that. And then how many numbers of inputs and outputs is there, அது இந்த மாதிரி இந்த டேட்டாஸ் வச்சு நீங்க பாத்துக்கணும் சார். ஓகே, that's all. And then power dissipation, delay, propagation delay, noise margin, how much value it can be allowable, அதெல்லாம் இதுல இருந்து கொடுப்பாங்க சார். So here the consolidation of values in this chart from the data sheets of your devices. ஸோ இதுக்கு யூஸ் பண்ணக்கூடிய டிவைசஸ்ல இருக்கக்கூடிய டேட்டாஸ் எடுத்து தான் இங்க கன்சாலிடேட் பண்ணியிருப்பாங்க. தட்ஸ் ஆல், நத்திங் நியூ. ஓகே, யூ ப்ளீஸ் டோன்ட் வரி அபவுட் சச் எ திங்ஸ். எஸ், ஸோ ஐ எம் நாட் கோயிங் டு எக்ஸ்பிளைனிங் திஸ், பட் எனிஹவ் இட் இஸ் அனதர் ஒன் இம்பார்ட்டன்ட் டாபிக். Either in your exam point of view or in your competitive examination, there will be a one question, 2 mark question is there. That is transistor logic. Transistor logic. That means all the circuits is designed only by using a transistor. அதனால தான் transistor. Each and every stage is designed by using a transistor. Okay, we will see its explanation diagrams for any gates, either AND gate or NAND gate or NOR gate in forthcoming session. But it has lots of sub classifications. It is given here. So this TTL is having many classifications. That means high speed transistor logic, low speed transistor logic, Schottky transistor logic, advanced Schottky, advanced level of Schottky transistor logic, low power Schottky transistor logic, and then advanced low power TTL, fast TTL. Okay, and then these are all the technologies available nowadays in an industrial application. Then it is only so far in the subject standard TTL is the subject la irukung sir. Idhula some classification, that means here positive pull up, totem pole output, and then open collector, then tri-state TTL logic. So in case in your examination any big question is there in this part அப்படினா இது நாலுல இருந்து ஒரு question வரும் sir. Definitely one question will be there in this part. So I repeat once again, we are going to discussing the operations of TTL in the next class only. But now it's a sub classifications. இதெல்லாம் இருக்குது, இதெல்லாம் என்னங்க சார் இண்டஸ்ட்ரியில யூஸ் பண்றாங்க. பட் in standardனா இந்த classifications தான். So we will discuss these things in a forthcoming session. Okay. So here what is meant by totem pole and open collector? So just you see the diagram and then we can leave it. This and all we will discuss later. That means here, here a circuit is given, its name is called 2 input TTL NAND gate. In the NAND gate என்னங்க சார் பேரு 2 input TTL NAND gate அப்படின்னு நம்ம சொல்றாங்க. சரியா? So இதுல என்னங்க சார் இங்க தான் இருக்குது input, here only we are going to take the output. Please listen why we called this as a TTL logic. All the things is designed only by using a transistor யூஸ் பண்ணி தான் சொல்லியிருப்பாங்க. சரி, there is a question may be possible, அப்ப இங்க இருக்கிற இந்த டயோட் எல்லாம் இருக்க சேர்த்துக்கலாமா? even if it is there or not there, it will be working condition. So நான் இப்ப இது ஏன் அப்ப யூஸ் பண்றாங்க? it is for protection purpose only, not for a operation. அப்படின்னா என்ன? there is not possible to giving any false triggering or malfunctions. அதுக்காக தான் இதை யூஸ் பண்ணியிருக்காங்க. or at least it gives a protection to the circuit. Similarly இது எதுக்கு? it is also to minimize any inrush currents or a higher current at the time of any operations. That's all. So இங்க ஒரு சர்க்கிள் போட்டிருக்கீங்களா, this particular arrangement is very important. This is called totem pole arrangement. So இந்த question என்னமோ இத்தனை கிளாசிஃபிகேஷன் சொல்லியிருக்காங்க, ஏதோ ரொம்ப கஷ்டம் நினைக்க வேணாம். all the circuits are almost similar, only just adding and removing. So இதுல இருந்து ஒரு பார்ட், இந்த டிரான்சிஸ்டர் TC மட்டும் எடுத்துட்டோம்னா we called that circuit is called open collector transistor logic. So இதோட சேர்த்து வச்சுட்டா totem pole transistor logic. அப்புறம் இதுல இன்னும் ஒரே ஒரு செட் ஆஃப் அரேஞ்ச் பண்ணிட்டோம்னா அதுக்கு ஒரு பேரு. That's all. Okay. So such a things as we will discuss in the forthcoming session. So far what we have discussed, some of the important definitions in a digital logic families.